Hello, in this video, we're going to give one more periodical trend of all of the elements, atomic radius. The radius is basically if you imagine all of the atoms to be a perfect sphere shape, okay, for instance, if we think about any atom, okay, like hydrogen, there's a nucleus in the middle, and then the orbits of the electrons are not just the circle, okay, it's actually a three-dimensional sphere. Then we can measure the radius of the sphere from the center of the nucleus. And basically, this is also the trend of size of atoms. Okay, we're trying to see relative size of the atoms on the periodic table. Again, we're not discussing the central atom here. Okay, we're only looking at the main groups here. Okay, the concept is very similar to the so-called electronegativity. Okay, basically, we're looking at when you are on top, upper half of the periodic table. Okay, you have lower number of layers, right? So we said that the first row or first period shows there are only one layer of electrons. When you have more layers of electrons, obviously you are getting bigger and bigger. So when you have two layers of electrons, it's going to be bigger than one. 3 is going to be bigger than the other two. And then when this number goes higher and higher, like at the bottom row, these atoms, they have 7 layers of electrons. So they're going to be so much bigger than the ones above it. So it's not hard to see, okay, the bottom row is when it goes up or on the column or on the group, you're getting smaller and smaller. Okay. Now, what about from left to right? It's actually the same trend. Okay, the left on the same period. Okay, of course, we're looking at on the same row. Okay, on the same row. On the same row, you have the smallest one over here, and you have the biggest one over on the left-hand side. The reason is that when you are on the same row, first of all, you have the same number of layers of electrons. For instance, starting from number 11, 12, sodium, magnesium, aluminum, on the third period, okay, all of these atoms has 3 layers of electrons. So let's see, when you have 3 layers of electrons here, 1, 2, 3. Everybody has 3 layers of electrons. So the size-wise, it doesn't really make it bigger when you have more electrons. Even though I know that you have 11 electrons, aluminum has 13 electrons, but since all of these electrons, additional electrons, are not getting you for any more layers, so the number of electrons doesn't really affect the size of the atom or the radius of the atom that much. What really makes a difference is the number of protons. So when you have 11 proton, 12 proton, 13 proton, okay, the bigger this number is, that means the stronger this nucleus is. Okay, more positive charge you have. And that means these stronger nucleus is able to pull these electrons closer to the nucleus, which make the actually atoms smaller. So the overall understanding should be this, okay, when you're towards the right, okay, the smaller one, in general, okay, the atoms tend to have more compact, more condensed structure, meaning the electron, the nucleus is pulling electrons closer to the nucleus, which makes them higher electronegativity, better electron taker as well. Whereas in general, when you are metal like these guys, okay, they tend to have weaker nucleus, so they don't have as strong as these guys when it comes to pulling electrons. So they have relative bulkier, bigger, loosened structure of atoms. So they tend to be better electron donor, giving out electrons instead of taking electrons from others. So this in general. Then another thing is, in this discussion, we do include noble gases. Okay, so this has nothing to do with octet rule. So overall, you can remember the trend here. The biggest, loosest, and the most bulkiest atom of all of the elements is francium down here. Whereas the other corner, helium, is the smallest, the most condensed atoms out of all of the elements. Okay. when you compare to, in general, when you're given questions about any other, compare size of elements, okay, for instance, between selenium and bromine, you can see from left to right, you are getting smaller, so selenium is bigger than bromine. Or if you're comparing atoms in the same group, okay, gamma is smaller than IN, which I'm not even sure what name of that is, but by looking at the relative position on the periodic table, you ought to be able to see their relative size of these two atoms. Or even possibly you can look at, for instance, let's say between neon and chlorine. Okay, what would you say? You can pause here, take a second, try it. Okay, so neon is smaller than chlorine. Okay, so it's more towards right up corner, chlorine is more towards lower left corner, which is the smaller trend. Okay, all right, so this is concludes actually the module 2.